Precipitation of insoluble salts. Welcome to this class. Don't forget to subscribe to our channel, refer others to this channel, ascend in grades, elevate your grades, elevate your future. This is the best place to be. Therefore, welcome again to this session, preparation of insoluble salts. It may be a brief session because we are only tackling this subtopic. Therefore, insoluble salts can be prepared by use of precipitation method, and this involves reaction of two soluble salts to form a soluble salt, a soluble and insoluble salts. But our main target is we have insoluble salts. So during such a reaction, because we are reacting to salts, then whatever happens is that the metal ions of these salts, they do exchange their anions during the reactions. So in such a reaction, the metal ions simply exchange their anions. And this type of reaction is called double decomposition. It is also the one that we call precipitation method. So you're supposed to know that we have some physical changes of the ions in these salts. We have some changes that occur in the physical states of these ions. So you need to note that in precipitation, reactions some ions undergo changes in their physical states. So for example, an ion can change from solid state to aqueous state. So during these reactions, we have some ions that participate during the formation of the salts, and others do not participate. So the ones that do not participate, in short, they do not change their physical states, then are called spectator ions. They are called spectator ions. So the ions that remain unchanged during chemical reaction are called spectator. Like the football fans, they are not in the field, but they are busy there cheering up. They are spectators. So now, during these two, during the reaction of these two soluble salts, then they will lead us to what we call ionic equations. So these spectator ions are omitted when writing ionic equations. When writing ionic equations. So this one is not taught in Form 2, but I will give it out. So conditions necessary for ionic equation to be written. The products must have either solid, liquid, or gaseous state product. So if you can form a solid, liquid, or gaseous product, then you qualify to write an ionic equation. But suppose you form all of them to be aqueous states, then you cannot qualify to write such an equation, or you call it ionic equation. We are going to give or go through several examples of these equations. We shall use all the methods to show the way out. Now you can arrive at the correct ionic equations. You're supposed to be aware of the valency of ions, both cations and anions. Number 2, you are supposed to be aware of their physical states. You also need to understand the soluble salts and the insoluble salts from the chart. And then you must also understand how to do the correct balancing of equations. So maybe I note them down. Beware of 1. Valencies of cations and anions. Number 2, their physical states. And number 3, how to balance correctly. Equations. So now I'll give out the example 1. We have barium nitrates. Salt reacting with zinc sulfate. Then we have been told that these ones will exchange their anions. So this one will go here and this one will come here. So what do we get? We get barium sulfate plus zinc nitrate. So you can, the first step is you write a well-balanced chemical equation, then after the word equation. That is the step number 2. So now there will be barium. We know that barium is valency 2. So barium nitrate will be written like this, since they have exchanged their valencies. Nitrate is valence 1. This one is in aqueous state plus zinc sulfate. Zinc is valence 2 and the sulfate is valence 2. This one is also still in aqueous state, so that we get zinc, we get barium sulfate like this. This one is in solid state because it's an insoluble salt. Then plus zinc nitrate. Zinc is valence 2, nitrate is valence 1. And this one will be in aqueous state. Now the next thing, we need now to break them into their respective ions. So how do you write barium ion? It is barium 2 positive. It is in aqueous state plus the nitrate. The nitrates are 2. They are 2, so nitrate is written like this. But we have something that we need to note. We have to balance this one. So it will be placed here so that it equalizes. It is in aqueous state plus zinc ion aqueous plus the sulfate ion, this is supposed to be negative, ion, it is also in aqueous state, so that this one leads us to this one, we'll write it in complete form because it is our main product, that we are after. Barium sulfate in solid state plus zinc ion still in aqueous state plus two nitrates still in aqueous form. So now if you look at this equation, there is somewhere where we said the ions that remain unchanged during chemical reaction are called spectator ions, and they must be omitted when writing ionic equations. So now if you get back to this, you look on the reactant side and the product side, then you will find that the physical state of this one did not change, the physical state of this one did not change. That is why you can see them being in common. So what you do is that you cancel them. So later on, we remain with barium ion plus the sulfate ion. You get your barium sulfate, which is an insoluble salt. This one becomes our ionic equation. So now it is that simple. Sometimes if you are aware of balancing and the products that will be formed, it is not a must that you follow the steps that I have given out. You can go straight to the formation of the product and you write direct ionic equation if in your mind you have the correct balancing. If all the cations and the anions are well balanced, then it will be easier for you to move on. Let's give out another one where we have lead nitrate reacting with potassium iodide. So in this case, we have said that we exchange the ions, so the anions, so the lead will pick the iodide, then the potassium will pick the nitrate. So what will happen here? You write their chemical symbols, or you write the chemical equation. So lead is valence 2. Lead nitrate like this. It is in aqueous form. Plus potassium iodide is written like this. Still in aqueous form. You're going to form lead iodide. Lead is valence 2, iodide is valence 1. So they exchange there. So this one will be in solid state plus potassium nitrate, which will be in aqueous form. So if you look at this equation, it is not balanced. So now you can see we are having 2 iodides here, we have 1 here. So if you place 2 here and add 2 here, then the equation becomes fully balanced. Therefore, we can now skip the second step. This one, you can skip the second step and just say lead reacting with the lead cation plus the iodide, the 2 iodide ions, then you are going to form the lead iodide solid state product. So we can say P2 positive plus the 2I, here still in aqueous, then you can get back, you can get the lead iodide direct. Why is this one simple? It is because in this equation you have already done what we call balancing. If you don't want to go straight, then you can use the shortcuts. So can go the long way. Where you need to break this down into its ions. So it will be lead aqueous plus 2 nitrates then you are going to get lead iodide solid plus this one, you break it, it will be 2K positive, it is in aqueous state, plus 2 nitrates. It's like we are balancing. So now this one is in aqueous form. So if you look at it well, we'll see that this one, sorry, there is somewhere I skipped. We did not break this one. So we are supposed to add potassium iodide, where there are 2 of them, potassium iodide aqueous plus 2 iodine aqueous still, that we get the lead iodide like that, solid state, plus the 2K positive plus the 2 nitrates. So if you look at this one, you'll find that this one did not change, this one did not change, so you cancel them, then this one will lead you to this equation here. The next equation, that is number 3, example 3. We have silver nitrate reacting with the sodium chloride. Then we are expected to form silver chloride. Silver chloride plus sodium nitrate. You need to ask yourself, what is the valency of silver? It is valence 1. So it is written as Ag. Nitrate is NO3. This one is in aqueous form, reacting with sodium chloride. and this one will land us to silver chloride. This one is an insoluble salt in solid state, plus the sodium nitrate, like that. This one is in aqueous state. So now I'll break this one down so that we can use either the long method. Yeah, for sure we use the long method, but at the same time we can also use the short way because it's already balanced. So let me explain how we are going to pick these ones. So this one is picking the chloride so that we can form these products, meaning that the sodium ion and the nitrate ion are excluded from the equation. Therefore, we can just say direct, it is Ag positive aqueous plus the chloride ion in aqueous, you get silver